When people think of classic aircraft from the 1960s, one name almost always rises to the surface first. Long, slender, impossibly elegant, faster than sound, and dripping with prestige. The supersonic airliner that became a symbol not just of aviation, but of ambition itself, Concorde. Concorde was glamorous, dramatic, and unforgettable. It carried movie stars, royalty, and CEOs across the Atlantic at twice the speed of sound. It looked like the future made metal, and because of that, Concorde tends to dominate the conversation whenever Britain's aviation achievements are discussed. But at the very same time Concorde was being developed in Britain and France, another aircraft was quietly taking shape on British drawing boards. An aircraft that could not have looked more different. Short, rounded, almost stubbornly unglamorous. It did not promise champagne at Mach 2 or a place in pop culture history. Instead, it promised something far more practical. This was the British Aircraft Corporation, BAC 111. The 111 was never meant to dazzle. It was not built to break records or make headlines. Its job was to do the unglamorous work of aviation, day in and day out. Short flights, small airports, tight schedules, quick turnarounds. It was designed to bring jet travel to places that had never seen a jet before, and in doing so, it quietly reshaped how modern airline networks work. That is why it earned one of the most revealing nicknames in aviation history, the bus stop jet. The nickname was not meant as an insult. It was a description of intent. The 111 was designed to operate almost like a bus. It would arrive at small, lightly equipped airfields, collect passengers, and shuttle them efficiently into major city hubs. From there, travelers could connect onward to long-haul flights on much larger aircraft. In other words, the 111 was a feeder aircraft long before the term became standard. To understand just how revolutionary that was, you have to place yourself in the early 1960s. Commercial aviation was still young. Jetliners were symbols of national prestige. Airlines competed on range, speed, and size. The dominant aircraft of the era were four-engine machines like the Boeing 707, the Douglas DC-8, and Britain's own VC-10. These aircraft needed long runways, extensive ground support, and modern terminals. What they did not do well was serve smaller communities. Across Europe, and especially in post-war Britain, the aviation landscape was very different from today. Many countries could afford to build only one or two large, fully equipped international airports. What they did have, scattered across the countryside, were dozens of small airfields. Many were leftovers from World War II, former grass strips that once launched Spitfires, Mustangs, and Messerschmitts. By the 1960s, some had been paved with concrete runways, but infrastructure was minimal at best. No jet bridges, no ground power units. Sometimes, not even a proper terminal building. This was the environment the 111 was designed for. From the very beginning, the aircraft was built around the idea of independence. It needed to operate without relying on airport equipment. That philosophy influenced nearly every major design choice. One of the most visible examples was the inclusion of built-in air stairs. Passengers could board and disembark directly from the aircraft without waiting for external stairs. Later variants even added forward air stairs, making the process faster and more flexible. This may sound mundane today, but at the time it was a major operational advantage. Equally important was the inclusion of an auxiliary power unit, or APU, in the tail. Today, APUs are standard. In the early 1960s, they were still relatively novel. With an onboard APU, the 111 could start its engines, power its electrical systems, and heat or cool the cabin without any ground support. That meant true self-sufficiency. The aircraft's low-slung fuselage further reinforced this concept. Sitting close to the ground made baggage handling possible without belt loaders or specialized equipment. Crew members could load luggage by hand if needed. The aircraft was designed around the realities of small airports, not the ideal conditions of major hubs. Even crew operations reflected this philosophy. The 111 was certified to fly with 2 pilots and 2 cabin crew, without a flight engineer. That was a bold move at a time when many jetliners still required 3-person flight decks. This concept would later become standard on aircraft like the Douglas DC-9 and the Boeing 737, but the 111 was ahead of the curve. In theory, operations could be almost bus-like. One pilot performed the walk-around inspection, the other prepared the cockpit. One flight attendant checked tickets at the rear stairs, while the other helped load baggage. It was efficient, economical, and perfectly aligned with the aircraft's mission. For airlines, this was revolutionary. Suddenly, it became economically viable to offer jet service from small towns and secondary airports. Routes that previously supported only slow turboprops could now be served by jets. Travel times dropped. Reliability improved. Passengers who lived far from major cities got their first taste of the jet age. And that is where the 111's true importance begins to emerge. The aircraft did more than just serve regional routes. It helped create the hub and spoke model that defines modern airline networks. Passengers could fly from small regional airports into major hubs, then connect onward to long-haul flights. This system may feel obvious today, but in the early 1960s, it was still a developing idea. The 111 showed that it could work. This feeder role also intersected directly with Concorde's story. Concorde needed long runways and specialized infrastructure. It could never operate from most regional airports. That meant it would always depend on subsonic aircraft to bring passengers to its departure points. In that sense, the 111 was not just a contemporary of Concorde. It was an enabler. There were also personal and technical connections between the two programs. British test pilot Brian Trubshaw, who would later become synonymous with Concorde, worked on the 111 test program earlier in his career. Legendary engineer Barnes Wallis contributed to both projects. While Concorde captured public imagination, the 111 quietly proved ideas that would later influence supersonic design. Beneath its plain exterior, the 111 was an engineering powerhouse. British engineers were deeply aware of the dangers of metal fatigue, thanks to the tragic early history of the de Havilland Comet. Rather than relying solely on traditional riveted aluminum skins, BAC used extensive machining and bonding techniques. Large structural components were milled from solid blocks of aluminum and bonded together, reducing stress concentrations and improving fatigue resistance. The aircraft was deliberately overbuilt. This approach made the 111 heavier and more expensive, but it also made it exceptionally durable. It was designed to withstand tens of thousands of pressurization cycles, an essential feature for an aircraft intended to fly multiple short legs every day. The landing gear was similarly robust, rated for repeated hard landings on short and sometimes rough runways. That structural strength would later save lives. In 1971, Pan International Flight 112 suffered a catastrophic dual-engine failure shortly after takeoff from Hamburg. The crew attempted to return to the airport, but were forced to make an off-airport landing on a German autobahn. The aircraft collided with an embankment and a bridge in a violent crash. Remarkably, the majority of passengers survived. Investigators later noted that the 111's structure absorbed enormous impact forces without collapsing. The reinforced fuselage maintained survivable space, allowing many occupants to escape. In an era when aviation safety standards were far less mature than today, this was a powerful demonstration of robust design. The aircraft's toughness showed itself again in the 1980s, when a Philippine Airlines 111 survived not one, but 2 onboard bombings. In both cases, small explosive devices detonated in the lavatory. In both cases, the aircraft remained controllable, landed safely, and was repaired and returned to service. Very few airliners can claim such resilience. The 111 also played a pivotal role in advancing flight safety systems. The first prototype crashed due to a then poorly understood phenomenon known as deep stall. a danger associated with T-tail aircraft. At high angles of attack, disturbed airflow from the stalled wing can blanket the tailplane, rendering the elevator ineffective. In response, BAC engineers developed systems to prevent this. Scenario: the stick shaker provided tactile warning of an impending stall. The stick pusher actively forced the nose down to reduce angle of attack before deep stall could occur. These systems became standard on T-tail aircraft worldwide and remain in use today. Once again, the 111 quietly changed aviation. While the 111's philosophy and impact are often discussed, its technical characteristics deserve attention in their own right. The aircraft was powered by two rear-mounted turbofan engines, typically variants of the Rolls-Royce Spey. These engines were well suited for short-haul operations, offering good thrust response, durability, and reliability. Depending on the variant, thrust ratings ranged from approximately 9,850 to over 12,500 pounds of thrust per engine. The BAC 111 featured a T-tail configuration, which helped keep the horizontal stabilizer clear of engine exhaust and wing turbulence during normal flight. The engines were mounted at the rear of the fuselage, reducing cabin noise and leaving the wing aerodynamically clean. This configuration also contributed to the aircraft's excellent short-field performance. Typical seating capacity ranged from around 70 to just over 100 passengers, depending on variant and interior configuration. The fuselage was narrow by modern standards, but well optimized for short flights. Cabin layouts emphasized quick boarding and disembarkation rather than luxury. In terms of performance, the 111 cruised at approximately Mach 0.78 with a maximum operating speed around Mach 0.80. Its range varied by model, but generally fell between 1,000 and 1,500 nautical miles, ideal for regional and short to medium-haul routes. The aircraft required relatively short runways, a critical feature for its intended mission. Takeoff distances were well within the capabilities of many secondary airports, and its rugged landing gear allowed operations from less than perfect surfaces. Avionics were advanced for the era, particularly in later variants. The cockpit layout emphasized crew efficiency, supporting the two-pilot concept long before it became industry standard. Despite all of this, the 111 faced commercial challenges. Its robust construction and advanced engineering made it expensive to build. Competitors like the DC-9 were cheaper and easier to produce at scale. The Boeing 737 would later dominate the market entirely, benefiting from aggressive pricing and continuous development. Sales numbers reflect this reality. While the 111 was successful and widely used, it could not match the sheer volume of its American competitors. Still, BAC was not content to stand still. The company envisioned larger successors, including the 211 and later the 311. These designs aimed to scale the 111's philosophy into the wide-body era, offering greater capacity while retaining robustness and efficiency. Ultimately, these projects were canceled when Britain chose to fully commit to the European Airbus consortium. Ironically, much of the 311's design thinking lived on. The fuselage cross-section and engineering expertise contributed to the Airbus A300, the aircraft that would launch Airbus into global prominence. In that sense, the 111 became a spiritual ancestor of the Airbus family. The aircraft's service life was extraordinary. Many examples flew for decades, moving from major airlines to charter operators and later to secondary markets. Ryanair used the 111 as its first jet aircraft. Others found second lives as corporate transports or flying test beds. Northrop Grumman operated several 111s as airborne laboratories for avionics and systems testing. The final airworthy example flew until 2019, closing a chapter that spanned more than 50 years. Half a century of service for an aircraft designed as a simple regional shuttle. That longevity speaks volumes. The 111 was never meant to be a star. It was meant to work, and work it did. It democratized jet travel, It shaped airline networks. It advanced safety systems. It influenced future aircraft design on both sides of the Atlantic. In many ways, its story mirrors the evolution of European aviation itself, from fragmented regional networks to integrated international systems, from rugged post-war airfields to modern global hubs. The 111 was there at the beginning, quietly laying the groundwork. So while Concorde may always steal the spotlight, it is worth remembering the small, chubby, unassuming jet that did the heavy lifting. The aircraft that made the jet age practical, accessible, and sustainable. Not bad at all for a bus stop jet.